Hi guys, welcome to my YouTube channel, and in this video I will briefly discuss about electric flux in sphere. In order to understand this topic, or in order to understand the electric flux in spherical shape or spherical surface, we will draw a sphere. In this sphere we will place a charge in the center of that sphere in order to understand the electric flux, because charge has a possibility to throw electric field lines spherically, so we need to calculate the electric flux in the whole sphere. First of all, the condition for calculating the electric flux is that the area of the spherical surface should be flat. But in this case, the spherical surface or spherical shape is not a flat, it is in sphere or curved path. So we need to cut this area in order to make the flat surface, because the flux is directly proportional to the electric field intensity and area of should be flat. So we will cut the sphere into small patches in order to understand, or in order to make the flat shapes or flat patches. So we will divide this area into small patches, so like just like a football, because as you see on the football there are different colors of patches connected or stitches around each other and make a football or spherical shape. So if we unstitch all the patches, the every patch is a flat shape. So the I have drawn a flat shape having a area delta A, and if we consider that the number of particles or number of electric field lines passing through this area will be E, so delta A is the small patch of area delta A, and number of electric field lines passing through this area will be electric field E. And if we calculate the number of electric field lines passing through this area will be a flux of that region. So the concept is same. In order to understand, or in order to calculate the total flux in the whole sphere, we will divide all the sphere into small patches like a football, as I have given the example of football, because in the books there is no example given and students cannot understand. If we unstitch all the patches of the football and if we place on the floor, all the patches are in flat shape. So this is a good example in order to understand the electric flux in spherical shape. So every patch is a flat, then it is very easy to calculate the area of every patch. So if we consider this is a first area or first patch, its area is will be delta A1. For the second patch, its area is delta A2, and so on. In order to understand this, every patch having the area delta A1, delta A2 and delta AN, there will be electric field electric field accordingly for every area. So our purpose is to calculate the total flux of total flux passing through every patch. So I want to redraw all the patches having area delta A1, and the electric field passing through this area, or electric field lines passing through this one, is E1, and the flux of that region will be phi 1. Similarly, for the area 2, the delta A2 is the area of that patch, and E2 is the electric field, and phi 2 is the electric flux in that region, and so on up to phi n. We need to calculate the total flux in that region, and total flux will be the sum of all the patches become a spherical shape, because these patches are extracted from these spherical surface. So the total flux will be E1 delta A1 plus E2 into delta A2, and so on, E3 into delta A3, and so on up to n particle. First of all, we have seen that the area of every region is similar, so electric field lines passing through every region will be similar, so magnitude of electric field lines will be same, which will be considered as E. So if we put the value of E in every case and find out the total flux, it will be easy to calculate. The total flux is known as phi is equal to E for every case, and if we take common, the final value will be delta A1 plus delta A2 plus delta A3 into E. So this delta A1, delta A2, delta A3 is the sum of all the patches of areas of flat areas. So if we make or sum all the patches, the total area will be the spherical shape of that area, and phi is equal to E multiplied by total area of spherical shape or spherical surface. Total area of spherical shape or spherical surface. So in order to further elaborate, phi is equal to E into the value of E is equal to 1 over 4 pi epsilon naught, because we have seen in the electric field force, then E is equal to 1 over 4 pi epsilon naught q over r square into area of sphere is equal to 4 pi r square, which is well known formula. And we can replace this total area of spherical surface with 4 pi r square. And as you have seen that some of the values can be cancelled out from these one, like pi can be cancelled out from this one, 4 can also be cancelled out from this one, and r square can also be cancelled out from this. So the total value of total flux is equal to q over epsilon naught. This is a total flux which is given and which is calculated in the total spherical surface. Q phi E is known as electrical flux of that region. So electric flux in the spherical surface is equal to q over epsilon naught, which does not depend upon the shape of the any region. If the shape is spherical, or if the shape is square, or if the shape is rectangular, or ellipsoid, or parabolic, the total flux of that region will be same, which will be q over epsilon naught. So this is the value generated for the region when there is no space, or there is no medium between the source and this spherical shape. It means that this spherical shape is hollow, and there is air between, or air between charge and surface of the sphere. This is a without medium or mediumless formula. Phi is equal to q over epsilon naught. But if we apply some medium, then what will be the value of flux? Either value of flux will increase or decrease, it depends upon the medium also. So q is equal to E phi is equal to q over epsilon naught into epsilon r, this which is known as relative permittivity. And this relative permittivity of is different for every material, or for different mediums. So when we apply some medium, or place some medium in the sphere, this medium is between spherical surface and the charge, then the flux may increase or decrease depending upon the value of relative permittivity of the medium. And these are two formulas, which is without medium, and with medium we can find out the flux from this region. Up till now we have discussed about the electric flux in sphere, and we have divided all the sphere in small flat surfaces in order to calculate the electric flux in spherical medium or spherical region. We have finished it, and if you have any question you can contact me at my email address and contact number.